Rocket scientists are known for being among some of the most intelligent people on the planet. But what if I told you that they've been using the same solid-state rocket fuel without any meaningful innovations for the past 60 years? Sounds unbelievable, but in fact it's true. This archaic fuel burns inefficiently, it limits range and payload capacity, and it produces caustic hydrochloric acid that damages the environment and destroys launch equipment. At Adronos Energetics, we have developed the next step in rocket fuel technology with a new product called Alitech. This fuel is 10% more efficient, 17% more powerful, and 99% cleaner and safer for the environment. And if that's not enough, it reduces launch costs by up to 45%. Now, Alitech will be used primarily in space launch vehicles as well as defense platforms. The main benefits of Alitech are enhanced range, increased payload capacity, and the fact that it's cleaner and safer for the environment. I'm going to talk more about these as we move throughout the presentation, but first let me introduce the team that's made this all possible. Dr. Brandon Terry invented Alitech while obtaining his PhD at Purdue University. He's our resident rocket scientist. He is an expert in propulsion technology and has numerous years of working experience in the Department of Defense. Chris Stoker, who was unable to attend today, he is a real estate venture capitalist and development manager. He has raised hundreds of millions of dollars in debt and equity financing and has a JD MBA from Indiana University. I'm Shane McGuire. I'm an MBA student from Purdue University. I have sales and marketing experience and have led multiple teams to quarterly sales of nearly $1 million. Our advisory board consists of Dr. Steven Sun. He's a professor of mechanical engineering at Purdue University. He's a propulsion and explosives expert. Ron Ellis is the CEO of a publicly traded biotech company. He's a management and fundraising expert and has raised hundreds of millions of dollars in fundraising. And last, but certainly not least, is Marsh Hurd, who has over 50 years work experience in the aerospace industry, working for Boeing and NASA, and has sat on different congressional committees and is our expert on regulatory affairs. Together, we are committed to bringing Alitech to market to solve the two main problems that have been plaguing this industry for over half a century. Now, that first problem is that plumes from traditional rocket fuel are destructive to people, equipment, and the environment. Take a look at the screen. You'll notice a rocket being launched and a large plume, a large cloud behind it. That cloud contains hydrochloric acid, and it does a few things. The first is that it's destructive to the equipment, resulting in expensive maintenance and upkeep of that platform. The second is that it's dangerous for people. That whole platform will need to be cleared off prior to launch. And third is that it produces that hydrochloric acid, which damages the ozone, damages the environment. So the soil and water contamination is a huge factor, resulting in expensive environmental remediation. In fact, in a study done by the University of Colorado, it states that if left unregulated, by the year 2050, solid rocket launches will result in more ozone depletion than ever was realized by the now illegal aerosols. It's a big problem. What Alitech does completely different is that it solves this problem by preventing the hydrogen and chlorine atom from even bonding during combustion. This makes it safer for people, it's safer for the environment, and it also greatly reduces environmental remediation and maintenance costs. The second main problem with traditional fuel is that it's terribly inefficient. Solid rocket fuel produces large molten droplets. These droplets are essentially large chunks of unburned fuel that break off and don't combust. They limit the overall maximum range and payload capacity of the rocket. Essentially, they are wasted energy. Now, what Alitech does completely different with these LMDs, these large molten droplets, is that it causes them to shatter. They micro-explode immediately after breaking off from the fuel. And this is caused because Alitech burns at a much lower temperature than traditional rocket fuel. Now, to further illustrate this point, I'm going to show you guys a video of a comparison of traditional rocket fuel with that of Alitech. See if you can notice the large molten droplets. Do you notice the difference? You can see with the traditional fuel, those glowing globules sort of launching off. Those are those LMDs, limiting the range and efficiency of that traditional fuel. With Alitech, you can see how violently it's exploding near the surface, and that's caused by those micro explosions, eliminating those LMDs. Now, all of this combined creates a significant performance increase. Alitech extends range of rockets by 25%, increases payload capacity by 65%, and it is 99% safer and cleaner for the environment. All of this combined represents a significant competitive advantage. Now, to use boxing as an analogy, the boxer with the greatest reach and most power has a significant competitive advantage over his opponent. The same holds true in defense applications. If I can launch a missile at my enemy from a range in which he can't actually hit me, I have that same competitive advantage. So what we're seeing is I can protect both myself and my equipment at the same time. Alitech also increases and provides a greater mobility. We can launch bigger satellites, larger space launch vehicles into orbit with less fuel, reducing the overall cost of moving into orbit. And finally, Alitech completely removes the negative impacts of traditional fuel on the environment, making it cleaner and safer, as well as eliminating expensive environmental remediation and maintenance costs. To put this into context, the two main manufacturers of solid rocket fuel hold in reserve $177 million for future environmental remediation expenditures. Now, we did a survey and actually with some armed forces representatives who've had experience with solid rocket fuel, and I'm going to read a quote from him. He says, "Corrosion is a major concern for the Navy, and a lot of money is spent developing new corrosion control methods. Eliminating a corrosion contributor will save money on maintenance costs and part replacements. Alitech can solve this problem." Now, the costs of Alitech, when normalized on a payload weight basis, are a lot cheaper. Now, there are four main drivers behind the standard rocket fuel system, and that is first, raw materials, manufacturing, second, equipment maintenance, and finally, environmental remediation. We've talked at length about the last two. When we normalize this on its scale, Alitech is 45% cheaper, meaning that we can launch the same size rocket for 45% less. Now, we've talked a little bit about the benefits of Alitech, we've talked about the cost, but just how big is this market? The US solid motor market is worth $3.2 billion. There are a few main players in this market, the first of which is the Department of Defense, NASA, as well as allied countries, or US allies. Now, Department of Defense we're familiar with, the Army, the Navy, the Air Force. US allies like Taiwan, South Korea, allied Middle Eastern countries, they actually represent a significant portion of this market, which is $1.28 billion in annual spend. The market demand has been consistently growing at about 5% annually. We're expecting that to continue to grow due to ongoing world conflicts, space exploration by NASA, as well as the privatization of space exploration that we're seeing with some of these new companies starting up. The way that we capitalize on this market is by focusing our marketing efforts on the end users, so the Department of Defense and NASA. Now, these marketing efforts have a dual purpose, the first of which is to gain government funding to finish the development of Alitech. The second purpose is to demonstrate the capabilities of Alitech so that they then will write government contracts specifying the use of Alitech in future projects. Now, we've had the opportunity to leverage Purdue University's extensive alumni network and meet with these end users. We've presented scientific papers and generated a lot of interest. And as we continue to gain their support, they will then specify the use of Alitech in future government contracts. We can then decide to either fulfill that contract, sell Alitech outright, or license the technology and collect a royalty. Either way, we're pretty open. Now, we've had a lot of validation from various end users, the first of which is the Army. They are so impressed with our technology that they have purchased their own materials and begun testing at their own laboratory in Huntsville, Alabama. The second is the Defense Threat Reduction Agency. After hearing a presentation from Dr. Terry, After hearing this presentation, they actually approached us about writing the SBIR solicitation for up to $2.2 million. We've finished that solicitation and are now formally applying for those funds. The Navy is interested in the use of Alitech for the Sidewinder missile and are writing an SBIR grant up to $2.2 million for us as well. And finally, DARPA is interested and has sent us a formal letter requesting an in-depth explanation of Alitech with the end goal of providing an additional $3.5 million in funding. That's almost $8 million. Now, future growth of Alitech is broken into 3 main phases. The first is where we're at now. We've already filed 2 provisional patents. We are in the process of earning phase 2 funding and finishing propellant characterization. During phase 2, this is lab scale tests where we'll launch multiple rockets and check on scale, see how it performs. We'll also work in networking with end users and earn phase 3 funding. And finally, phase 3, which is tactical scale, so larger defense applications. And then at this point, we'll also look into lobbying for regulatory reform consistent with preventing climate change. This actually helps further strengthen our position in this industry. Now, we need capital for continued business development, and this is mainly because we've got $8 million of potential funds for funding. However, this can only be used to fund technology development. That's how the government grants work. So in terms of staying afloat over the next 3 years until we can actually produce profits, we need $550,000 in order to continue business development. Now, our estimated financials are consistent with our growth, which is we're expecting to fund Alitech primarily through the development of awarded funds and federal grants. During phase 3, we can decide to license or sell the technology. But either way, by year 5, we're looking at $1.4 million in net profit. The history of warfare is incredibly simple. Whoever can throw the biggest rock the furthest, the most accurately, is going to win. Now, we can either remain in the past. We can use this archaic, costly, expensive, damaging fuel, or we can join the rocket fuel revolution. We can ensure competitive advantage and protect the environment. Thank you.
So my question goes to the heart of your 3 value propositions, specifically one of them, and that's the cleaner one. Mm-hmm. So you talk about it being 99% cleaner and safer. And what I want to understand, and this pertains to market sizing, is whether this even matters. And I'll tell you what I'm getting at. So you talk about the US and you talk about US allies. I'm more interested in the countries that are not allies. Russians, Chinese, Middle Eastern countries that aren't allies that are going to buy this. And I want to understand what percentage of the market that constitutes. Because in my mind, I'm thinking if 70% of the missiles and rockets that are launched every year are done by non-allies, then this isn't going to make much of an impact. So you get what I'm trying to do? A little bottoms-up analysis.
Sure.
So help me here.
So if I'm understanding right, you want to know, do they really even care about the hydrochloric acid or the cleaner? So when you launch some of these vehicles, say these space launch vehicles, the hydrochloric acid is going to corrode the entire launch area, which means now, say you're at NASA or any other launch facility, you have this giant infrastructure of equipment that now has to be completely scrubbed down, resurfaced, painted, and all of this between another launch. You look at us and all of our allies where we have missiles on these ships and cruisers. Every time they launch those, you've now completely corroded all of the metal on the surface of these ships. These are very expensive, time-consuming tasks that look at it.
Yeah, so you're not answering my question with respect to the environment and the ozone layer. And what I'm trying to understand is, I'm trying to get a number. If 70% of missile and rocket launches are done without your technology, then it becomes a moot point because the ozone layer is still going to be hurting.
Yeah, I mean,
So
the
give me a
fact of the matter
percentage and
is,
tell me how you built this.
because we've developed this technology in the United States with the help of a university, we are limited to who we can actually sell this technology to, which is what your point is, right? So in terms of environmental impact on a global scale, it's tough to quantify how much we're making a drop in that bucket.
Right.
It's hard to quantify. It's a fluff factor, but it works here because it saves us a whole lot of money in environmental remediation and maintenance. And that's the advantage for US companies. Outside of that, the market, we can't even market to anyways, right?
Right. So why make that claim? Why don't you just focus on the first two pieces and then the corrosion aspect instead of going after the whole environmental ozone depletion aspect?
Because it's still important for us here at home. I mean, we care about protecting the environment for the most part. The federal government's just interested in the fact that, one, we got bigger range, two, bigger payload, and if we can help protect their equipment more, that's why hydrogen, or the getting rid of the acid is important to them. Fair point.
So, well, first let me congratulate you on an energetic presentation.
Thank you.
Thank you. Was it explosive for you?
And secondly, just before I get into my question, just on the topic of climate change, as far as I can tell, neither any of the armed forces nor Congress has yet identified that as something they care about. So, corrosion, yes.
Corrosion,
Climate change,
absolutely.
no.
Yep.
All right?
Yes,
And
we
who cares
absolutely
if the
agree.
Russians or the Chinese corrode their vessels? Nobody. But as far as the ozone layer, if they don't use your fuel, it ain't gonna fix the ozone layer. But I'm gonna move on to, can you put up your funds flow statement on the screen for me, please?
You bet.
Switching gears entirely.
This one?
No, funds flow.
There we go.
No. I'm looking for a financial statement that is like the third statement after the income statement and the balance sheet.
Sorry, we didn't include it on the presentation. It's in
Right,
your
and you
business
didn't include it in the materials. And here's the problem I have. I'm trying to understand what kind of equity you're trying to raise and explain the damn security that you're selling to me because I couldn't even figure it out.
So in terms of an equity statement within the company, we're looking for $550K, right?
I couldn't tell that, okay?
Yeah. So it's in the business plan. We are told that you had copies of the business plan. However,
We do, but I honestly, without a funds flow statement, I saw that you were raising 3-point-something million worth of private capital, but I couldn't figure out where it was coming into the company and what the investor was getting. And you just said it was 550, so help me understand that.
Sure. Yeah, so the development of Alitech is primarily going to be done through government funds, which takes care of pretty much all of our R&D. What we need is money to float the company until we can raise revenue, which is by year 3. So the equity stake in the company for that $550,000, obviously that percentage is negotiable, right? It sort of depends on our valuation of the company at the given time, which those funds are presented.
So what is the valuation that you're selling the security at, and what is the security you're selling?
I mean, at this time, we have in the business plan $1 million based off of the IP alone, but we're expecting that to increase.
For valuation?
For the valuation.
Of just IP.
We're expecting it to increase very rapidly as we continue on finishing phase 1 and entering phase 2 testing. That valuation should increase as our technology readiness level increases.
So as an investor, I'm mystified what you're asking me to do. Help me understand.
Yeah, so
I'm not, other than the Defense Department.
No, you're fine.
Or NASA, as a private investor, what do you want me to do?
We want funding to be able to float the company until we raise revenue. So
How much and what do I get?
$550,000, 10% equity stake in the company.
Okay, I didn't see that anywhere, but okay. So what is my return? Because it looks to me like you've got some kind of a real estate waterfall that caps my return at 4 times my investment at best.
Yeah.
Am I reading that correctly?
Yeah.
Why would I want to do that?
It's your decision.
Absolutely.
It is.
I'll hand it off.
All right, since Bob has the finances covered, I'm going to go back to your market opportunity. So you talk about the SRM spend is $3.2 billion.
Correct.
That's on the rocket motors. How much is the spend on the fuel?
That is the fuel.
That is a fuel spend?
That's based off of the documents from the public. There's 2 manufacturers of solid propellant in the United States, Aerojet and ATK. And based off of their publicly traded documents, we can back calculate how much they're spending and off of just the fuel, not the whole motor system.
Okay.
That's just fuel.
And ATK manufactures fuel?
Correct, in northern Utah.
And so you have it on the business plan here that ATK is interested in partnering with you. So are they your competitors or they're partners?
They have mentioned that they might want to partner. There's nothing formally set there. They are, in fact, our competitor in the fact that our biggest barrier to entry is that they need to adopt our fuel, versus using the traditional technology that they have. But
The fact is, when the government specifies for a government contract that they want this type of fuel, the manufacturers need to find a way to supply that. So we can either, like we said, we can license that technology, we can sell that technology to these manufacturers and sort of make an exit, or we can fill those contracts outright. It's not likely that we're going to fulfill them because that's hundreds and millions of dollars in sort of equipment and maintenance just to even be able to produce the fuel. So more than likely, they'll either license that technology from us or purchase the technology.
So your strategy is to go to the government to make them mandate to use your
Correct.
fuel?
Exactly.
Correct.
Because once they specify it, they have to use it.
I see.
And we have the secured IP around the technology. So we can then decide whether we sell the company the full rights to them, license, or see if we can somehow partner and fulfill those contracts ourselves.
My questions center around the the executive summary. In the third paragraph, you talk about efficiencies of 10% in rocket fuel efficiency, 17% in ISP, unit of mass, I guess, propulsion metric, and then 99% in the green aspect. I think we were all in agreement that generally those users aren't even really thinking about environmental impact. But then in your presentation, you focused on 25% increase in range. You focused in 65% in payload improvement, which to me sound like really competitive advantages, right? Absolutely. I'm just curious why you didn't lead with that, because when we talked about this in our caucus before, we were kind of scratching our heads, is 10% enough to really get someone's attention in terms of efficiency? Yeah. I think 65% in payload absolutely would be, and 25% in range. Why aren't those covered more in depth in the business plan?
Well, I believe they are covered in the business plan.
Or the executive summary, like when we keyed in, it just didn't jump out, right? The 3 metrics that we thought were the key things were the 3 that you list right up front. And I'm just curious, are they downplayed in this because maybe they're harder to realize, or where do those 2 metrics fit in, range and payload?
Yeah, there's sort of an overlap, right? So the increase in efficiency and that increase in ISP, so specific impulse, is what leads us to these greater range and payload capacity. And so we sort of introduce it initially to sort of get you thinking, but ultimately we should clarify it. What really matters is that we can get 25% greater range and 65% greater payload. You nailed it on the head.
So yeah, I know we're not doing feedback, so I'm not, but I kind of want to lace my question or comment with this cruel reality of all of this entrepreneurial thing. And that is, a lot of times the best ideas, smartest people don't win because it's about ability to execute.
Sure.
And I think that includes capital, seeking capital. Like what are you selling and how much is it? I heard 2 different prices, by the way, just in this pitch. I heard $1 million and then I heard $500K for 10% or $5 million pre. So, I think you guys really need to focus in on that mechanism and make it clear, what are you asking of investors? Sure.
Yeah, my turn. So I'm gonna hammer on that. What I see in your offering section is a very, very unusual structure for paying the investor back, which has what I would tell you is you cap the investor, basically. I give you my money. I don't, at least what this says, I don't get equity, I get cash flow. And you may find people who will invest in you on that basis, but I don't know any of them. And I've been raising money for about 30 years. How did you guys arrive at this? And how would you defend it if I'm going to give you all $550,000 that you need? How in the world would you convince me to actually write that check on this basis? I mean, I see that it's good for you,
Sure.
but in all the deals I've done, fair is a two-way thing. You get a deal when both sides agree that the deal is fair.
Yeah.
And this strikes me that this was written to be fairer to you than to me. Now, by the way, I want to tell you guys, I loved everything else I heard.
Okay.
I loved everything else I heard. But I don't think this flies. So help me.
I agree with you that we need to look more at how the equity stakes will go on the private financing. We've really been trying to, minimize the amount of private equity financing we need to bring in, trying to work primarily off of the government grants, and that's been our main priority. And I do agree that we need to work more on that before we get in front of an investor to have a more favorable.
Well, I've raised money for 6 companies across 35 years, and I've never seen this before. So you don't really want to go in and be a pioneer in financing structure. That's not the place where you need to be disruptive.
2 minutes, Jim.
Okay.
I have a question on your product development.
Yes.
Where are you with regards to proving the scalability of the commercialization?
Yeah. So that's the start of phase 2. We're just finishing up phase 1 of development right now. Phase 2 is where we scale it. We start getting larger and larger lab scale rocket motors to where we end up getting fairly large size.
How long is that phase?
A year.
A year, maybe a little longer. And at the end of that, we'll know the scalability, and that'll be the last major risk involved with the technology development.
Historically, though, as rockets scale in size, especially with the little bits of fuel that we've been burning, we've been seeing really great results. Historically, those results get better as you begin to scale, at least with rocket fuel. So we're very positive that it's going to continue to scale properly.
So would you test it with a live launch? How would you, you're testing in a lab with some mini prototypes, right? How are you doing it in real life?
Yeah, so we're testing it right now, very small samples. But these are not launched into the air. They're launched on the ground, strapped down, so we can measure all these different metrics in it. And we're measuring the performance of that and comparing those to traditional fuels, because we'll have, the basis is to compare against.
I see.
Can I ask a question? Go back to your back to your slide that shows the $3.2 billion. Who among those customers, where we're coming, that one right there,
Yep.
Who among those customers cares about range and payload and why?
You got 20 seconds to answer.
Every one of them. Why? Because it's a significant competitive advantage. If I can hit my enemy from a further distance and they can hit me, I'm going to win. It's also a deterrent.